Hello and good afternoon, and welcome to this video tutorial on OSPF stub areas. This is going to be the first in a four-part series where we're actually going to cover not only the OSPF stub area, but I'm going to do separate videos for the Totally Stubby Area, the Not-so-Stubby Area, or the NSSA, and the Totally Not-so-Stubby Area, or the Totally NSSA. And so as you can see, the topology we're going to be working with is over here on the right-hand side of the screen. We've got router 3, router 1, 7, 4, router 5, and router 6. And pay special attention here to the OSPF areas. So between 5 and 6, we're OSPF area 3. Between router 7 and 4, we're OSPF area 2. Between router 3 and 1, we're OSPF area 1. And our backbone area is here, and this is actually representing just a switch, and these fast Ethernet 00 connections from each of these three routers, 1, 5, and 7, are in the switch, right? So we've got a multi-access segment here. All right, so let's go ahead and talk about stub areas. And for a lot of learners, a lot of new learners who are new to OSPF, one of the confusing things with OSPF is when you start to deal with multi-area OSPF, and we clearly have a multi-area OSPF set up here with the backbone area in addition to three other areas, areas 1, 2, and 3. And then when you start to talk about, excuse me, the different area types, right? So we're concerned about the stub area. Now, the one thing to remember about a stub area is that there are no Type 5, oops, back that up there, no Type 5 LSAs in a stub area, right? So you can see here we've got our Type 5 LSAs are going to be queued up right down here because we've got external networks, right? And remember, this is going to show up as an E2, okay? And I'm just redistributing this 192.168.100.0/24 is simply being redistributed into OSPF off of router 6. So let's go ahead, let's take a look at what our area setup looks like before we make any changes. So I'm on router 3, so I'm just going to say show IP route. And as you can see, we clearly have an OSPF external type 2 route, and it just happens to be that redistributed, or that external type 5 LSA for 192.168.100.0. I'm going to go over to router 4 as well, which is over in area 2, and let's see what router 4 sees. So we'll say show IP route, and sure enough, router 4 also sees the external type 2, right, which is the default type for an external network, type 5 LSA, and it's for the 192.168.0/24. So just like EIGRP, you have the option when you're faced with a scenario where maybe a router only has a single path out of the network, right, like router 3 here. There's only one way out of this network, so why not make it a stub, right? Because there's some certain benefits to making this router, in this use case here, a stub. It's going to shrink the size of the Link State Database, or the LSDB. If we were taking in, let's say instead of a single external network, we had 500, 5,000, 50,000 external networks showing up on router 3, if router 3 only has one way out of the network, which is the serial 000 interface here, over to router 1, does router 3 need all of that external, all of that type 5 external network information to make a decision on how to get to those networks? And the answer is no, he doesn't. And so one of the things that we can do in order to control that is to transition router 3, or simply area 1, into a stub area, right? And so that's kind of the entire concept of a stub, is that it is not going to allow type 5 LSAs. So it will continue to allow the type 1s, the type 2s, if this was a multi-access segment, it's not here, but it would continue to allow the type 2s, as well as the type 3s, the inter area, right? You can see we've got 2, and this is router 4 here, but router 3 is going to show us the same thing, right? We've got some inter area routes that we're picking up. So those are type 3 LSAs. However, we're interested, we don't want to see any externals. We just want a default route. And so what's going to happen, excuse me, when we transition this area into a stub area over here, is that when this type 5 LSA shows up here at router 1, router 1 is an ABR. And if this is set up as a stub area here, right, area 1 becomes a stub area, the ABR is going to recognize that because in the hello packets, right, there's a bit called the E bit. And ironically, you can think of it as the external bit, right? And we're going to take a look at the RFC here in a second. So when the E bit, when the E bit is set, right, that's for external routes, okay? When the E bit is clear, what that means is on the LSA, right, the E bit needs to be clear or it's not going to get propagated. So again, the E bit must be clear for all routers in an area to be a stub. And so the E bit sits in the hello packets that float back and forth between these guys. So when the ABR goes to put the type 5 LSA into area 1, it's not actually going to put the type 5 LSA in there. It's actually going to generate a default route, a type 3, an inter-area default route. Because again, remember, the stub area, there are no type 5 LSAs allowed, right? So the ABR is going to generate a type 3 default route that is going to be seen over here on router 3. And again, router 3 only has one way out of the network over to router 1. And again, that E bit is inside the hello packets, right? So we'll put E bit and hello. And we're actually going to debug it, and we'll see what happens when one side gets set to a stub. We'll do router 3 first here, and when router 1 has not been set to a stub, and there's going to be a mismatch in the hello packets, and the adjacency is not going to form. All right, so let's go ahead and take a look at that. On router 1, we're going to go ahead and kick off a debug here, and we're going to say debug IP OSPF hello. Whoops. We're going to debug IP OSPF hellos. Now we should see some output. There we go. So router 1 is getting hellos from router 7, router 3. You can see that we've picked up the all OSPF routers for the, for the 224.0.0.5, right? So now let's go ahead and on router 3, let's enter the command in that we would need to put in here to change area 1 to a stub area. So we'll go to router OSPF 1, and I'm simply going to say area 1 stub. And that's it. That's the command that we need on router 3. Now, when we come over here, let's take a look and see what happens on the hello packets when he receives the next packet from router 3. And I'm going to go ahead and stop it right there. So we'll say you all. So what do we see here? So received hello from 3333, area 1, and then it gives us that transit network 10.10.13.3. Says hello from 10.10.13.3 with mismatched stub transit area option bit. And so the problem is that router 1, and you can see the dead timer expired, right? So our adjacency with router 3 went from full to down. Because again, we have mismatching transit area option bits in the hello packets. Because router 3 is configured to be a stub, therefore he has cleared the E bit from the hello packets. Router 1 has not cleared the E bits from the hello packet. However, router 3 has. And so that's why we're seeing this error. So if we were to take a look over here at the RFC, and the RFC that I'm looking at is 2328, which is the RFC for OSPF version 2. If we were to search on E bit, you can see here that the external routing capability, so the entire OSPF areas can be configured as stubs. And we'll take a look at 3.6 here. So an AS external LSA, right, Autonomous System External LSA, which is a Type 5 LSA, will not be flooded into stub areas. The capability is represented by the E bit in the OSPF options field. In order to ensure consistent configuration of stub areas, all routers interfacing to such an area must have the E bit clear in their hello packets. Right, and this talks about the hello packet options field. Excuse me. It says the E bit of the options field should be set if and only if the attached area is capable of processing AS external LSAs. In other words, Type 5 LSAs. So we're changing it to a stub area, and we just did that on router 3, so now the E bit has been cleared. However, router 1 still has the E bit set, because router 1 still believes, hey, I'm capable of dealing with AS external LSAs, Type 5 LSAs. So here we go. If the E bit is set incorrectly, the neighboring routers will refuse to accept the hello packet. And that's what we're seeing right now, because again, there's a mismatch in the options. All right, so let's go ahead and add the configuration to router 1 that's going to make this successful. So router OSPF 1, and again, very simply, area 1 stub. And that's it. So if I were to say do debug IP OSPF hellos, we're going to see now that the hellos that we're receiving are no longer mismatched. In fact, you can see that the adjacency went from loading to full. And if I were to say actually let's go do you all. So if I were to say do show IP OSPF neighbors, you can see that my adjacency now with router 3 has been reestablished, right? So let's go back over to router 3. So again, the key consideration and the key use case for an OSPF stub area is, 1, I only have a single exit point out of the network, and router 3 meets that criteria, and 2, I want to, optimize the size of my Link State database. And I don't want to receive any Type 5 LSAs. In fact, remember, when router 1, who is the ABR, receives the Type 5 LSA, he is going to issue to router 3 a default route, which is a Type 3 default route. So again, stub areas, what are the LSA types that you can find in stub areas? You can find a Type 1, a Type 2, or a Type 3. What LSAs are we not going to find in a stub area? You're not going to find a Type 4, you're not going to find a Type 5, and you're not going to find a Type 7, right? And we'll talk about Type 7s a little later when we get into the not-so-stubby areas. All right, so if I say show IP route, let's take a look here. You'll notice that the Type 5 LSA is gone. However, what do we have here? There is our default route, which is a Type 3 inter-area default route. So if I were to say show IP OSPF database, you can see that the size of my database now, I've got my router link states, which are my Type 1 LSAs. I've got my summary link states, which are my Type 3s, right? So no network link states here. If I were to go over to router 1 and say do show IP OSPF database, you can see that I've got some net link states here, right? Because I'm on a multi-access segment. And router 3 is not. This is a point-to-point link. So there will not be a network link state here, right? We've got our Type 1 for the routers, and we've got our Type 3s. Again, Type 2s, if this was a multi-access segment, we would see Type 2s, however, it's not. But what we're not going to see here, irrespective of the type of network, we're not going to see Type 4 LSAs, we're not going to see Type 5 LSAs, and we're not going to see Type 7 LSAs. So inside of a stub area, the only LSA types you're going to see are going to be Type 1, Type 2, or Type 3. And as you can see, we're seeing those right here. Here's our Type 3s, right? And here are the type 1s, okay, for our router link state LSAs. So if I were to go back over to router 4, now you'll notice that router 4 is very similar here. So this same LSA is making its way through the backbone area, and it's coming out here from router 7 over to router 4. Router 4 is still going to see an external type 2, or I'm sorry, yeah, external type 2 route, which is a type 5 LSA. So if I were to say show IP OSPF database, what do we see? Because remember, this is not a stub area. So here is my type 5 AS external link state, and what is it? It just happens to be the 192.168.100. And remember, we are not seeing the type 5s over on the other side, right? And here's your summary ASB, your type 4, right? So if I were to say show IP OSPF database, we've got some options here that we can choose from. So if I were to say ASBR summary for the excuse me, autonomous system boundary summary, right? We have a link state entry for that, and the advertising router. So who's advertising this to us? It's router 7. So what is the ASBR? It's 6.6.6.6, and the type 4 tells us how do we get to those external routes, right? So the type 4 is going to help us and tell us, hey, here's where you need to go to get to these type 5 external routes, right? So again, if I were to do show IP OSPF database and external, and I only wanted to see the external LSAs, there it is right there. There's my type 5. Advertising router is 6.6.6.6. And again, remember, this is why the type 4 is needed, right? So if I only got the type 5, I would see that the advertising router is 6.6.6.6, but I wouldn't know who advertised it to me, right? I don't see that here. What I see is, I see that the originating advertisement came from router 6. I don't see that router 7, which is what we saw with the ASBR summary, right? Who's the advertising router that's advertising this external type 5 to me? It's router 7, right? Okay, so right now router 4 does not see, I'm sorry, router 3 does not see any of those entries. So if I were to come back to router 3 and say show IP OSPF ASBR, database ASBR summary, there are no entries. What if I were to say show IP OSPF database external? There are no entries, right? So only type 1, type 2, and type 3. So database router, we're going to see the type 1s, and here they are, right? So if I were to say net for the network, type 2s, but we don't have any type 2s. And what about my summaries for my type 3s? So here are my type 3s, and we should have one here for, and there it is, the 0000, which is being advertised. So who's advertising that to me? Router 1. Because remember, when that LSA showed up here, that type 5 LSA showed up here, and we had already declared that we are a stub area. We do not want type 5 LSAs in here. Router 1 then says, you know what? Not a problem. I'm auto-magically going to generate a default route for you, and it's going to be a type 3 LSA, an inter-area LSA. All right, so that pretty much wraps up an OSPF stub area. Again, I'm going to be doing 3 more videos. We're going to talk about the totally stubby area, the not-so-stubby area, and the totally not-so-stubby area, and some of the nuances with those. We took a look at the RFC that talked about the EBIT in the hello packets and how the EBIT must be clear in the hello packets in the area for all routers in that area if that is going to be a stub area. And remember that a stub area will not take or will not show or advertise type 4, type 5, or type 7 LSAs. You're going to find type 1, type 2, and type 3. All right, so this wraps up OSPF stub areas, and now we're going to talk about next is the OSPF Totally Stubby Area. Thanks for watching. Have a great night.